Okay. Next also is just a continuation of the previous slide, but here we will try to investigate the spectral signature in a detailed manner. So we are comparing different objects now, and these objects are vegetation, bare soil, clean water, and turbid water. This slide actually describes these 4 different types of objects. This is clean water or clear water. Here on the other side, this is the turbid water. This is a soil which is supposed to be bare, and this is green vegetation. Okay, so when we are taking an image of this area from a satellite, which is about 700 kilometers above, and then for a particular set of pixels, we plot their reflectances, then most likely we will get a curve as shown in the slide itself. For example, if we are trying to analyze these pixels and trying to plot their reflectance percentages with respect to the wavelength, here you will see in the blue range we have a lower percentage. Then towards the green, this is increasing. Towards the red, this is decreasing. And something is making it grow very large in this area. So VGR roughly is within this range from 6 up to 0.7, so it is within maybe this range. So remember that our naked eye, or the sensors that are present in our eyes, it can only see up to 0.7. That means from here we cannot see, or the sensors present in our eyes cannot capture any information. So from 0.4 to 0.7, which is the dominant range in terms of reflectance. From the graph you will see that around the green range it is higher, or the highest. That is why vegetation appears to be in green color. Then when we cross 0.7 mark, and then we are engaging a larger wavelength in the process of data collection, you will see that this reflectance percentage is shooting up. But unfortunately, with our naked eye, we do not see anything in this range. So this actually falls in the near infrared zone. So that means anything that happens in the near infrared region or the infrared region is beyond our capability to look at. But that does not mean that things are not happening in that range. Things are happening, and very much happening in that range in terms of the reflectances. But even our naked eyes cannot see what is happening here, or this higher amount of reflectance. We can build sensors which actually can measure this, and we build it. We construct sensors which are capable of capturing information that is happening around the near infrared region. That means anything that is beyond 0.7. So if we design a sensor on board a satellite, this sensor should be able to capture this information. That means this higher reflectance in the near infrared. And that is why you see this whole curve. So once you cross the near infrared region, again this drops. Then if you further increase the wavelength, it takes a shape like this. And then with further increase in the wavelength, it ultimately drops. So there is something that is actually helping this reflectance to shoot up extremely high compared to the rest of the curve in the near infrared region. Remember, we are talking about the vegetation. What is it? As you remember in the beginning of the slide, I said that there must be something in the molecular and the chemical level that is responsible for the amount of energy that is being either reflected or emitted from these objects. So what is present on the leaves are the chlorophylls that is mostly responsible to shoot up the reflectance in the green range, and the same thing is responsible to shoot up the reflectance pattern farther higher in the near infrared region. If our naked eyes were being able to see this information in any color in the near infrared region, we would have seen all the trees, mostly all the trees in that particular color, because you see the dominance of this reflectance in the near infrared region. Okay. Similarly, okay, this is actually an average which is coming out from many trees, different types of trees and the leaves. And this is a typical spectral signature for vegetation. Coming again to this bare soil, which is shown by the magenta color, it represents the reflectance pattern of an averaged bare soil from many, many pixels on the surface of the earth. What is a pixel? We'll describe it later. So you see in the blue range, it has a less dominance. You enter the green range, it is increasing, and towards the red range, it increases further. That is why bare soil, if you look at the right side, is predominantly in red color. When you enter the near infrared, it keeps on increasing, but unfortunately, you cannot see it. And with the increase of the wavelength, it keeps on increasing, but our human eyes have a limitation. From 0.7 onwards, we cannot see anything that is happening. But sensors can capture this information if we construct or design a sensor in order to capture this information. Again, clean water, you see a higher reflectance in the blue region, and all throughout the x-axis there is a drop. That is why if you see water in blue color, probably it is clean water or clear water. Again, if it is a shallow or turbid water, this blue range, the amount of reflectance is less than the one that is happening in the green range and the red range. This is because of the mud that is there with the water. So it takes the shape of this inverted U. Initially, it keeps on increasing till we reach green, then red, again starts decreasing, and in the near infrared it drops significantly. So this is about the spectral signature of various objects. We are talking about these 4 different types of objects, but all the objects on the surface of the Earth, they have their unique signatures. And as I said, the beauty of the subject is that if you connect the signatures with something that you know from a distance of about 700 kilometers, you can tell what these objects may be, or you can guess rightly about the properties of these objects. Okay, we will stop for the time being until we go for the next lecture. Thank you.